Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals. And in this session I will solve this problem where we are given a function f which is given to be differentiable function, and this function f of x, it satisfies this relation, that is f of x is equal to square root of 3 over 2 plus integral 0 to x square root of 1 minus f square u du, right? So here we have the function that is the square of the function f of u, and then we have to find f of pi, right? So let us see how easily we can solve this problem by using the concept of uh, derivatives and one important property of definite integrals. So let us start. So here we are given this relation, right? Now what we will do, we'll differentiate both sides with respect to x. So we'll write d by dx of f of x, and here the derivative of root 3 over 2 is 0 because it is a constant, and then we have d by dx of 0 to x and square root of 1 minus f square u and du, right? So dy dx of f of x is simply f prime of x, and here d by dx of this integral is simply equal to square root of 1 minus f square x. That is, we'll replace this u by x. So here we have used an important result from definite integrals, which says that if we have a function, say y is equal to the integral from a to x, and here we have say g of u du, then the derivative of y with respect to x is simply g of x, right? So if we compare this integral with this one, then the lower limit is a is equal to 0. Here a is a constant, and x, here the upper limit is x, here also the upper limit is x, and g of u is given by square root of 1 minus f square u, right? So when we find out the derivative of this integral with respect to x, then we simply replace this u by x. So we have now f prime of x is equal to square root of 1 minus square of the function, that is f of x. And now this is a differential equation of first order and first degree. So now we have to solve this differential equation to get the value of f of x. So now to solve this differential equation, let us write f of x as simply f, just for convenience, right? And f prime of x as df over dx. So we'll use these notations just for convenience. So f prime of x can be written as simply a df over dx, and here we have square root of 1 minus f square, right? So separating the variables, because this differential equation is variable separable form, right? So we can separate the variables. So we have df over square root of 1 minus f square, and here we have dx. Now integrating both sides with respect to here we have x, and c is the constant of integration, right? Now this is a well-known integral, because we know that integral dx over square root of 1 minus x square is equal to sine inverse x. So now the integral of df over square root of 1 minus f square is simply a sine inverse of f, right? And in the right hand side we have simply x. Integral of dx is x, and c is the constant of integration, right? So now we can write f is equal to sine of x plus c, right? So now again using the usual notation for f as f of x, we can now write f of x is equal to a sine of x plus c. So this is the form of the function f of x, and we can see that f of x is a sine function. Now our next aim is to get the value of this constant of integration c, right? So let us find out this c with the help of some condition. So now let us take x is equal to 0 in the given equation, right? So when we take x is equal to 0 in this equation, we have f of 0 is equal to square root of 3 over 2 integral 0 to 0, and here we have square root of 1 minus f square u and du. Now clearly this term is 0 because here both the limits of integration are 0. So we are simply left with f of 0 is equal to square root of 3 over 2. Now let us use this condition to get the value of c, right? So what we will do, we'll take x is equal to 0, and f of 0 is equal to square root of 3 over 2 in this equation. So we have sine inverse f is given by square root of 3 over 2, and x is 0, and here we have c. So we have c is equal to sine inverse square root of 3 over 2, which is equal to pi over 3, right? So sine 60 degrees, that is sine pi by 3, is equal to square root of 3 over 2. So the value of constant of integration c is equal to pi by 3. So let us take this value in this relation. We have f of x is equal to sine of x plus pi by 3, right? So this is our required function f of x, and let us find out the value of f of pi by taking x is equal to pi, right? So we have f of pi is equal to sine pi plus pi by 3, right? And sine pi plus pi by 3 is minus sine pi by 3, because we know that sine pi plus theta is equal to a minus sine theta. Now sine pi by 3 is root 3 over 2, and here we have the negative sign, right? So the value of f of pi is given by minus square root of 3 over 2. Now here it is important to note that while calculating the value of the constant of integration c, we have taken x is equal to 0, and f of 0 is equal to square root of 3 over 2, right? And if we take x is equal to 0 in this equation, then we have f of 0 is equal to sine 0 plus c, that is simply equal to sine c, and f of 0 is root 3 over 2. So here we have root 3 over 2 is equal to sine c, right? And root 3 over 2 is equal to sine pi by 3, and we have now this equation, that is the trigonometric equation, sine c is equal to sine pi by 3, right? So if we use the concept of general solution of this differential equation, this trigonometric equation, then we can write c is equal to n pi plus minus 1 raised to n, and here we have pi over 3, right? So if we take the general solution and we have to find out some other values of c, then we can also make use of the concept of general solution of this trigonometric equation. So in that case, c is given by n pi plus minus 1 raised to n pi by 3. So in the present case, we have just considered the value of c corresponding to n is equal to 0. So when we take n is equal to 0 in this general solution, then the value of c is simply given by pi by 3, right? And in that case, the form of the function f of x is given by sine x plus pi by 3. So to summarize this discussion, we can easily conclude that as per the requirement of the given problem, we can use the different values of C from this general solution, right? So assigning different values to n, we can obtain different values of this constant of integration C, and accordingly the form of the function f of x can be taken. So in the present case, we have just taken n is equal to 0, and corresponding to n is equal to 0, we have c is equal to pi by 3, and our function is given by f of x is equal to sine x plus pi by 3. So accordingly, using this relation, we have calculated the value of f of pi. Hello viewers. In today's session, we are going to discuss another important and conceptual problem from integration. And in this class, we are going to discuss this important problem where we are given a function f which is defined as f of x is equal to 1 plus 1 over x times the integral from 2 to x, and we have f of u du, and we have to find out the value of f of e, right? So here what we will do, we'll first solve this equation and to get the form of the function f of x. So once we get the function f of x, we can easily find out the value of f of e by substituting x is equal to e, right? So to solve this problem, we have to make use of the concept of derivative and an important theorem from definite integrals, right? So let us solve this easy problem by using the concept of derivatives and definite integrals. So let us first multiply throughout by x, right? So we have the equation f of x is equal to 1 plus 1 over x integral 2 to x f of u du. So let us multiply throughout by x. So we'll get here x times f of x, and here we'll get x, and then here we have this x and this x get cancelled, so we have the integral 2 to x f of u and du. So this is the first step in solving this equation. Now let us differentiate both sides with respect to x. So we have here d by dx of x f of x, and here we have d by dx of x, and here we have d by dx of the integral 2 to x and f of u du. Now here we can make use of the product rule, that is the derivative of the product of u and v, which are functions of x. We have u dv by dx, then we have v du by dx. So here the first function may be taken as u, that is x, and second is v, that is f of x. So we have x, the derivative of f of x is f prime of x. Then we have f of x, and the derivative of x is 1. And here the derivative of x is 1. And here the derivative of this integral is simply f of x, because here we can make use of an important property from definite integrals, that is, if we have y is equal to the integral a to x, say f of u du, then the derivative of y with respect to x is given by simply f of x, right? So this property is being used over here. So we have here simply f of x. So now we have x, f prime of x plus f of x, and this is equal to 1 plus f of x. Now f of x and f of x get cancelled. So we have simply x f prime of x is equal to 1, and f prime of x is equal to 1 over x. So now we have a simple differential equation here, that is d by dx of f is equal to 1 over x. So we can simply integrate both sides with respect to x. So we have integral df over dx, and here we can write dx, and here we have 1 over x dx plus c. C is the constant of integration, right? And f is f of x. So here we have simply f of x, that is f, and here the integral 1 over x dx is simply natural log of x, and c is the constant of integration. So now the function f of x is given by this expression, and we have to find out the constant of integration by using some condition, right? So here to get the condition, we'll here substitute x is equal to 2, right? So taking x is equal to 2 in the given equation, we can see that we have f of 2. Here we have x is equal to 2, then here we have 1, and here we have 2. Here we have 1 over 2, and then 2 to 2 because x is 2, and here we have f of u and du. Now the value of this integral is 0, being because here the limits of integration are same. So the lower limit and the upper limit both are same, so the value of this integral is 0. So we have simply f of 2 is equal to 1. Half times 0 is 0, so this is simply 1, right? So when x is equal to 2, f of 2 is equal to 1. So let us impose this condition on this equation. So here taking x is equal to 2, we have f of 2 is equal to natural log of 2 plus c, and f of 2 is 1. So here we have 1 natural log of 2 plus c. So c is equal to 1 minus natural log of 2. So taking this value of c in this equation, we can now write f of x is equal to natural log of x plus 1 minus natural log of 2. So our function f of x is now given by this expression, and we have to find the value of f of e. So let us take x is equal to e in this function. We have f of e is equal to natural log of e plus 1 minus natural log of 2, and natural log of e is 1. So we have 1 plus 1 minus natural log of 2, that is 2 minus natural log of 2, right? So the required value of f of e is given by 2 minus natural log of 2, and this value can also be expressed like this. We can write 2 as 2 times natural log of e minus natural log of 2, and this is natural log of e square using the properties of log, and here we have natural log of 2. So again, using the properties of log, we have natural log of e square over 2, right? So f of e can also be given by this expression.